In this video, we're going to finish the topics of chapter 3. We are now going to focus on energy and nutrition. We just defined what is energy. We even looked at the energies in terms of its classification of kinetic versus potential. And when it comes to energy and nutrition, what we're looking at is the potential energy that is contained in food products and beverages. In food products and beverages, we have specifically chemical energy present, and it is stored in the carbohydrates, in other words, carbs, in the proteins, in the fats that are in those food products. In order to have a balanced energy and nutrition, it is important that there is a balance between the calories in the foods and beverages that are consumed and taking into account what are the calories that are utilized due to body functions. And at times we need to look into physical activity. To understand how physical activity actually spends energy, we can see that in the bottom we have an illustration of somebody that is practicing swimming. 1 hour of swimming uses 502,000 calories of energy. Now, I know that this number seems very, very large. And when it comes to the values that maybe we are going to be more familiar with, understand that we are going to be looking more often at units of kilocalories. The equality states that 1 kilocalorie equals 1,000 calories. So, with this in mind, take the value of 502,000 calories and convert it to kilocalories. The energy that is stored in food, as I just mentioned a few moments ago, that chemical energy can be calculated by doing experiments. We have instruments that are called calorimeters that specifically will be looking at that chemical energy that is stored in food. As a summary, in a calorimeter, what happens is that the food sample that you're interested in is going to be burnt. That's going to release energy, which is going to be captured by a temperature difference in water. And that's what's utilized in order to calculate the energy value of food. We can see a figure here for a calorimeter, and we can see the components of a calorimeter, which include a stirrer, ignition wires, the water, we have food sample, we have a steel combustion chamber, we have the overall container, which is insulated, and lastly, we have a thermometer. As I just mentioned, overall, if you have a food sample and you're interested into or interested in looking at what is the energy that is stored in that food sample, pretty much what happens is that the food sample is placed inside of the steel combustion chamber. Because inside we have oxygen, the ignition wires will be able to allow to have that food be combusted. And in that combustion reaction, heat will be released. We can see that it is illustrated here in the form of a flame. When that occurs, overall, we have that heat release into the water. You can see the squiggly lines that I'm doing to represent the heat that it is exerted by the food sample. The stirrer is going to make sure that that heat is distributed evenly. And our thermometer will look at the temperature of water overall before the food was combusted and after the food was combusted. In other words, the thermometer is going to capture what is the temperature of the water before the flame was formed and it released heat versus after. And with all of the data that is obtained here, then scientists can determine how much chemical energy is contained in food products. In everyday life, if we look at food labels, there is some of this information that has been already incorporated onto the data that we have available to us. Many countries utilize the unit of kilojoules in order to look at that chemical energy in food. But in the US, we use nutritional calories. And the difference between nutritional calories and the energy calories is when it comes to the shorthand, nutritional calories are written with a capital C. And in addition, when it comes to value, one nutritional calorie equals 1,000 calories. In other words, a nutritional calorie equals 1 kilocalorie. In table 3.7 in the textbook, we have typical energy values for the 3 food types that are contributing energy in foods. As I mentioned before, those 3 biomolecules that contribute to that energy include carbohydrates, fat, and protein. We can observe that we have the example of a nutrition facts label, and we can derive where is the information that we have here for the calories per serving, given all the stuff that we have in our food label. Let's understand that overall nutrition facts label or food labels in general are going to give you more information than just the carbohydrates, the proteins, and the fat. At times, we see information like vitamins that are contained or important elements that are needed for nutrition. So understand that there's much information that is present there. But when it comes to calculating specifically the calories found in the food, all we look at is at the fat, the carbohydrate, and the protein. So let's illustrate how per serving this food label, which is specifically for crackers, there's 14 crackers in a serving. How do we obtain that 120 nutritional calories? So when we make a list of our fat, which in this food product is 4 grams, our carbohydrates, I'm going to shorthand it as carbs. I'm going to do it as 19 grams. And lastly, when we look at our proteins, which is 2 grams, we can refer to table 3.7 and see that specifically every gram of fat contributes 9 nutritional calories. So in order to do this, I'm going to multiply that 4 times 9 kcals or nutritional calories per gram. The units of gram cancel. And we can observe that specifically in this food product, the fat contributes 36 kilocalories or nutritional calories per serving. Let's move on to the carbs. For carbs, we can see that every gram of carbohydrate contributes 4 kilocalories. So we're going to multiply that 19 times 4 kcals or kilocalories. So when we do this calculation, we have 19 times 4, which means that we have 76 kilocalories being contributed by the protein, sorry, by the carbs. And lastly, we do the calculation for the protein. For protein, we can see that every gram of protein contributes 4 kilocalories. In other words, 4 nutritional calories. Let me be consistent and cancel the units of grams. So protein per serving in this food sample is going to contribute 8 nutritional calories, or in other words, 8 kilocalories. So when I take 36 plus 76 plus 8, I find out 120 kilocalories are present per serving. In other words, because 120 kilocalories equals 120 nutritional calories, notice the capital C, that's where this value comes from. Let's do a couple more examples to understand this concept a little bit further. So here we have a food product that I found online with its nutrition facts label. We can see specifically that this is protein chewy bars from Nature Valley. First question that we have here, what is the serving size in grams? And when we look at our nutrition facts label, we can see that on average, the serving size per bar is going to be 40 grams. That's where we find that information. Next, we are going to do the calculation for how many calories are in one serving. And understand that one serving is specifically one bar. So, just in case if you cannot read them clearly, in this food product, we have specifically, when it comes to the carbs, the fat, and the protein, it has 14 grams of carbs, it has 12 grams of fat, and it has 10 grams of protein. So with this information, calculate what's going to be in units of kilocalories per gram the total amount of calories in one serving. Next, based on the values total that you find for just the carbs, just the fat, just the protein, determine what is the major source of calories, meaning it's either going to be the carbs or the fat or the protein. And remember that we're going to be obtaining from what is the result of taking this number, multiplying it by 4, taking this number and multiplying it by 9, and this number and obtaining it and multiplying it by 4 and seeing what is the result. The one that has the largest value is your major source of calories in this food item. To conclude this topic, let's actually look at problem 3.32 from the textbook. And specifically, I'm going to focus on problem C. Problem C, we have to determine what are the kilocalories in 1 can of soda if it has 40 decimal place grams of carbohydrates, no fat, or protein. So for letter C, since I am interested in looking at the kilocalories, I can say that when I look at the carbs, I look at the fat, and I look at the protein, this food product has 0 grams of fat, 0 grams of protein. It is all carbohydrates. So since I have 40 decimal place grams of carbohydrates in this food product and I'm interested in the kilocalories, I'm going to utilize these values, which means that I'm going to take that 40 grams and multiply it by 4 kilocalories per 1 gram. So I'm going to cancel the grams. And then I find that when I take 40 times 4, that equals 160 kilocalories. In other words, 160 nutritional calories. Since my values of fat and proteins equal 0, if I multiply it by any number, it's going to equal 0 overall. So for this food product specifically, only the carbs is what's contributing calories to the food product. You can also try calculations by completing letters A, B, or D in problem 3.32.